Right. In the last unit, we solved applications of right triangles, and now we're going to solve some more involved applications of right triangles. And then in the next unit, we'll be solving triangles that do not have a right angle in them. Those are called oblique triangles. And so this first one requires you to use two right triangles. And so we start by we'll just read through the problem. You're taking your first hot air balloon ride, and your friend is standing on level ground 75 feet away from your launch point. You're ascending rapidly. At one instant, the angle of elevation from the camera is 22.5 degrees. 1 minute later, the angle of elevation is 75.3 degrees. How far did you travel to the nearest tenth of a foot during that minute? So we want to start by labeling the triangle. And so there are two triangles in here. We know that the launch point is right here. This is your launch point. And your friend is standing 75 feet away with a camera. So this distance right here is 75. This is where the camera is. Right. The angle of elevation from the camera to the balloon is 22.5 degrees. That's at one instant. So the first motion, okay, the angle of elevation is 22.5 degrees. Then a minute later, the angle of elevation is 75.3 degrees. So now this first angle is from here to here. Right? We measure from here to here. The next angle is from here up to here. That's going to be your 75.3 degrees. The question is, how far did you travel to the nearest tenth of a foot during that 1 minute? So the distance that we're looking for is x. We don't know how far we traveled in that minute from the point where it was 22.5 degrees angle of elevation to the point where the angle of elevation was 75.3. So what I'm going to do, I'm going to label this first distance A and this second distance B. And what we have two different triangles, and if it helps, you can draw the triangles separate. But in the end, what we know is that in order to find x is going to equal the distance B minus A. Right? So if I can find B and I can find A, I can find x. So let me pull the two triangles out. The smaller triangle is going to be, this is 75. The distance is 75. The angle is 22.5, and then A. The second triangle is the larger triangle. Those two triangles share the base, which is 75. And get the right angle, and this is B. And now this angle is 75.3 degrees. So I know that the tangent of 22.5 degrees is equal to A over 75, or A is equal to 75 times the tangent of 22.5 degrees. I also know, using the second triangle, that the tangent of the 75.3 degrees is equal to B over 75, opposite over adjacent again. And so B is equal to 75 times the tangent of 75.3 degrees. So I know that x is going to be equal to B minus A, or 75 times the tangent of 75.3 degrees minus 75 times the tangent of 22.5 degrees. And so we mentioned before that when you're solving a problem, you should not round until the end of the problem. So we want to carry as much as many decimal places as we can until the end. So I wouldn't evaluate A and B separately. I would just evaluate straight in my calculator, just typing this expression in. 25 tangent 75.3 degrees minus 75 tangent of 22.5 degrees. So x is approximately equal to 254.8 feet. Now there is another way of, and I know we've stored values before. I want to refresh your memory how to store values in the calculator. So you can evaluate A and B separately and just store all those extra values in your calculator. So if I go in and I just say, all right, I'll evaluate A, 75 times the tangent of 22.5 degrees, and I hit enter, I hit the STO button, which is right above the on, store, and I want to store that in A. And A is right above the math key, so I hit alpha math, and so I'm storing the value for A in the capital letter A, or in the variable A. And then I want to do 75 times a tangent of 75.3 degrees, and I want to store that value in alpha B, and alpha B is right alpha apps, and we hit enter. And so now that I have those values in there, I can just hit alpha B minus alpha A, and I get the same exact answer I got by typing them directly in. So that almost seems like more work, but if you know you're going to use a value in a future portion of a problem, it's nice to know how to use the store keys on your calculator. All right, in the next video we'll look at problems involving bearings.